Hey, what's going on, folks? It's Mike here, and welcome to my next lesson in the D programming language series. In this lesson, we're going to continue talking about generic programming, and this time talking about function templates. So again, this is a way to reuse functions with different types of data types or template parameter types to, again, write more generic code. So with that said, let's go ahead and dive into the D programming language website and see some examples here. So I'm going to go ahead to documentation, the language reference here, and we're going to go ahead and scroll down here and try to find, here's templates. We'll click on that. And today we're going to be looking at function templates specifically. So I'm going to go ahead and move this over for a second here. And we're going to talk about specifically just this example here and sort of set it up here. So I want to first start off by just giving us some definitions here, meaning I want to understand just the form of this. Now, we looked at this in the previous lesson, so you can check that out in the playlist if you need it. But as far as how this template looks like here, I'll go ahead and write T square, T after it, uppercase T again, and then a lowercase t. And then we've got the rest of the function here, which I'm just going to put with ... So again, this is the template parameter list here. Template parameter list. And that is ultimately what determines, again, what's going to get substituted in this function. So here could be the type here for this argument here, T. And that's the basic idea. It's just doing a textual substitution. So that's the main thing that we have to think about. In other languages, you might be used to having like angular brackets here. In D, we just use left and right parentheses, which I found very, very clean here. So that's the idea. And then this is the template argument. Again, that's substituted. Okay, so hopefully that's relatively clear what's going on here with these functions. We can use things like auto here. So we can use auto as well to just deduce the type if it's able. I tend to prefer to use auto here for the actual type here and let the compiler deduce things, because sometimes it can catch it. For instance, if I have multiple template parameters here and we get some result that maybe doesn't match, it's a nice way to catch things. So something to keep in mind here. Now draw your attention to the example down here where we're actually using the actual template parameter list here and supplying an integer here. Okay, so that's the basic idea. So I have square. Let me do this in black again, and I'll try to write it out neatly. Int, and then a 3 here. Okay, so this is our regular parameter list. Okay, parameters list, or arguments when we actually supply them. This is the template parameters, and those come after the explanation. Okay, so again, if you're coming from another language that uses like angular brackets, again, we use the exclamation mark. It actually parses things nicely in the D compiler. It's a little bit more searchable. So again, I like the exclamation mark here. Okay, so if we have, and there's some other little caveats to this. If you only have one parameter, you can actually get away with only, or you can omit the left and the right parentheses, again, just to save you some space here. What we're going to find out here in this lesson is we have this fun thing here, which is the last topic that we'll cover before we get into some coding, is implicit function template instantiation, IFTI. You don't have to remember that full name here, but basically what that means is if I compare this line below with this line, observe that the compiler is smart enough to just deduce that, yeah, I've got in my parameter list a 3. That's an int type, so no need to even specify that. Okay, so and this can even work if you have multiple parameters. So it's pretty neat, pretty cool thing in the D programming language. Okay, so hopefully that clears up some definitions here. I'll leave this page up and let's just go ahead and write some function templates here. And you will observe, I skipped over this, that what we learned in the previous lesson with the template code blocks, this is what it's sort of lowered to for this particular function here. So you can see the actual work that's the compiler is doing, and it's building this template code block. Again, we could write this code if we want ourselves, but this is just, again, a shorter syntax for us. So anyways, let's go ahead and write the square function here. That's going to be my argument. I tend to use longer names for the actual variables. So again, I'm just substituting value instead of t so we don't mix things up. And I could just return value times value. And let's just go ahead and store the result as a result of square. I'm going to be explicit with int here and pass in a 5. And let's actually do a couple of these just to show you the different syntax here. I'll do result 1, 2, and 3. So again, I can omit the parentheses here, and I can actually just put in the parentheses like this. Let's go ahead and write those out here. Result 1, 2, and 3. Okay, just to see a few different examples here. Oops, let's see. This would be line number 11. So I can actually get rid of this exclamation mark here. There we go. And we'll get the same result. Again, these are all equivalent ways to write the same function template instantiation. This one below being the implicit function template instantiation. IFTI is abbreviation. Again, not something that you have to remember, but just to know that it is available and why you don't sometimes have to specify with the exclamation mark. Again, if you like being explicit, you can just use this. Again, that's usually fine. That's usually, not a bad idea. Again, it can make things a little bit searchable in your code, but that's just something to keep an eye on. And I will also show you that here at line number 3 here, I can also just use auto, for instance, to deduce the type, and that works just fine. Okay, so let's play around with this just a little bit more. Let's write another function here. I like to do simple functions like, let's write one like add, and we can have, we could reuse this value here. T, again, because it's just doing a substitution. Let's just do A plus B here. How about that? And that'll work just fine here. Okay, so let's go ahead and create another result here. And let's just do add 5 and 4. And I'll write out result number 4. And this should work just fine here. Okay, so 5 plus 4 is indeed 9. Okay, and let's say that maybe we want another version of add here. And maybe we want to be explicit though. So we are allowed to have specializations in our function. So I could say this type is when I'm doing integer math here. I'm just going to write out an integer version here. It'll actually call this particular version of our function here. So you can put a colon in an integer here. And then you'll see that's, again, what's being printed out here versus, let's just do another result here. In fact, I'll extend this here just so we can see all of our lines of code. And let's do a version. And let's actually, let's test out our compiler, see how good it is, where I use 5.0f and 4.0f, right? So that should give us the floating point version here. And let's do like 4.1 and 5.3, something like that, okay? And we'll see that we get the 9.4, but it didn't print out integer version. Okay, so that's just using the generic version here. And effectively, every time that we instantiate or make use of a class here, even if it's a little bit hidden, right, you don't see the exclamation, but we know because of the implicit function template instantiation, D is in fact creating some other function like this for us. Okay, so somewhere, even though we haven't done it explicitly, the compiler is going to make the version for us for a float. Okay, so that's, let's just be explicit about that. Code generated, or roughly generated, right? We saw how it was loaded or lowered to that template form to, support the whatever version of the template that we're using here. So this is for when we use the add float version here. Okay, and what do we do? 5.3 plus 4.1. Okay. So as soon as you instantiate or use some different version with a different type or different template parameter list, you'll get a new function of that code. So we are creating potentially lots of code. That is one of the trade-offs with generic programming. But if this is the right thing to do, this is the right thing to do. And in some ways, it's easier to debug if we know that we have like the floating point version, or if we write a specialization, we can still see how it's called into it. But it is just something to keep in mind that we're generating different versions of code. Now let's see how well we do here. If I just use like 4 and 5.3 for result number 5 here. Let's see, do we still get the right result? Yeah, we get 9.3 here. What if I do something like this here and I put 5 and 4.0 here? Okay, that gets me 9. Let's try 4.5. Okay, so it seems like it's working here. And we do get 9.5 here. So D is smart enough to figure out that, it's not just looking at necessarily the first type here that we have, but it is going to, look at both of these types and figure out, what's the lowest common denominator in various cases. Okay, so just keep that in mind. if we're not sure, let's go ahead and write another version of add, just to show you what happens when we use two parameters here. And I'm just going to do T and S here. Okay. Let's go ahead and try to write this. Still working. Let's see if we can make it call the two parameter version here. So again, just playing around with, let's see which one gets called. In fact, the two parameter version is being called here with T and S here. Okay. That's kind of interesting because it gives you a little bit of insight that D is going to try to find, the best match here. Found two different parameter types here. Let's go ahead and try and see if I just put 5.1, so with just one type here, if it calls the one parameter version. Okay, so let's go ahead and write out one parameter version. Okay. Let's see here. I think now it's getting a little bit ambiguous here. So it doesn't know here, or there's no difference, essentially. Right? It's telling us that it matches both this version here that has one argument here that instantiates, or this version here. Okay, so just something to keep in mind here. With the different overloads here, we can run into situations where we're ambiguous. Don't have to panic. What I'm going to do here, though, is just for the purpose of this video, we would probably not want to have a two parameter version here. But let's just use this one here. Again, just so you can see the two parameter versions being called. And again, I just want to show you that, yes, I don't have to specify both of those arguments here. I could, if I want, I could do a version where I say treat this as a double and an int here. Again, just to show you that would still work. And Auto is smart enough to figure out that, yeah, this should actually be a double value here. Okay, so there are some things that you have to pay attention to, but D overall does a really nice job with handling templates. It's one of the superpowers of the language. Let's see here. I'm going to go ahead and just comment this out here because that's probably not how I'd write an add function here. Now, the last things that I want to show you that I think are kind of interesting are even just looking at WriteLine here, right? This is a function that we've looked at. If we go to the help pages here, so function WriteLine here, you'll find out that WriteLine is something that takes a list of template parameters. I'm going to leave this as a little bit of a sneak peek for what we'll talk about later on in this series with generic programming with the ... But WriteLine is this function that we've been using all along. If you've been wondering, hey, how can I write out all these different variations of types and so on? So that's kind of neat to know about here. Alrighty, folks. So anyways, with that said, I'll go ahead and leave you here. Feel free to follow along your progress. You can find a distraction-free environment at courses.msha.io. And otherwise, I hope you enjoyed this lesson, learned a little bit more about the powers of templates in the deprogramming language. It certainly is one of the super features of the deprogramming language. So we're going to keep talking about this, so I'll look forward to otherwise talking to you then. Thanks, as always, for your time and attention, folks. See you in the next one.